Hello, my name is Dr. Steele, and welcome to Steele Mathematics, where lessons in Algebra 1, Geometry, Algebra 2, Pre-Calculus, and Calculus are taught. And today, we are going to talk about 3 theorems that are derived from similar triangles. So the first one is the triangle proportionality theorem. It says, a line segment that is parallel to one side of a triangle splits the other two sides proportionally. So in this case, if segment MN is parallel to segment BC, then the length of segment AM over the length of segment BM equals the length of segment AN over the length of segment CN. So this is the triangle proportionality theorem. Now, before I introduce the second theorem, I want to introduce to you a concept, and that concept is the mid-segment. The mid-segment is a line segment that connects the midpoints of two sides of a triangle. Segment OP is the mid-segment because points O and P are midpoints of line segment AB and line segment AC, respectively. In other words, O bisects line segment AB and P bisects line segment AC. So now that we know what mid-segment is, we could talk about the second theorem, which is the mid-segment theorem. A mid-segment of a triangle is not only parallel to the third side, but it is also 1/2 the length of the third side. So we have two things happening in this theorem. First, segment OP is parallel to segment BC, and the length of segment OP is 1/2 the length of segment BC. So now we have the third theorem, the triangle angle bisector theorem. A bisector of one of the angles of a triangle splits the opposite side proportional to the other two sides. In other words, if line segment AD bisects angle A, then the length of segment BD over the length of segment CD equal the length of segment AB over the length of segment AC. So what I'm going to do now is I'm going to show you examples of how those 3 theorems are used. So if you look at number 1, here we have a line segment that bisects an angle. Therefore, we will apply the triangle angle bisector theorem. So we're going to call this X. The triangle angle bisector theorem says X over 6 equal 15 over 9. So this is how it is set up. So now we're going to cross multiply. This would be 9x equal 90. Divide both sides by 9 and you would get 10. And therefore, the solution is 10. Next, we have number 2. We know that there are 2 segments that are congruent, and that makes this a midpoint, and that makes this a midpoint. Therefore, the mid-segment theorem applies, and that line segment is supposed to be 1/2 of the third side. Therefore, 1/2 of 16 is 8. All right, number 3, we have a line segment that is parallel to one of the sides of the triangle. Therefore, we apply the triangle proportionality theorem. That's 15 over 10 equal 9 over, and let's call this x. So now we're going to cross multiply. This would be 15x equal 90. Divide both sides by 15, and you will get 6. All right, number 4. Again, we have an example of a line segment being parallel to one of the sides. So we apply the triangle proportionality theorem. So we're going to call this line segment x. So we have x over 6 equal 15 over 5. Cross multiply, we get 5x equal 90. Divide both sides by 5, and you would get 18. So the solution is 18. Number 5, we got a line segment that bisects one of the angles. So we apply the triangle angle bisector theorem. So that would be 10 over 15 equal, we'll call this side x, x over 27. We're going to cross multiply to have 270 equal 15x. Divide both sides by 15. And you will have 18 equal x. So the solution is 18. All right, finally on number 6, we know that this is a midpoint and this is a midpoint. So we apply the midsegment theorem, which also says that the line segment is parallel to the third side of that triangle. Therefore, we have this angle and this angle. They are consecutive interior angles, and they're supplementary. Therefore, 180 minus 67 is 113 degrees. So now, let's look at some more examples. Let's say you are to find the value of x. All right, so number 7, well, this is a midpoint and this is a midpoint. And we have the mid-segment theorem that says that not only that line segment is 1/2 the third side, but it's also parallel to that third side. So now we have this angle and this angle. Those are corresponding angles, and corresponding angles are congruent. So we have 4x plus 3 equal 5x minus 6. Subtract 4x from both sides, and you will have 3 equal x minus 6. Add 6 to both sides, and you'll have 9 equal x. So the solution is 9. On number 8, we have a line segment that bisects one of the angles. So we apply the triangle angle bisector theorem, which says 7 over 3 equal 3x minus 1 over x plus 1. So we're going to cross multiply. We have 7 times x plus 1 equal 3 times 3x minus 1. We applied the distributive property. We got 7x plus 7 equal 9x minus 3. We subtract 7x from both sides, and you have 7 equal 2x minus 3. We add 3 to both sides, and you have 10 equal 2x. Divide both sides by 2, and we have 5 equal x. Therefore, the solution is 5. On number 9, we have a line segment that's parallel to the third side. So we applied the triangle proportionality theorem. 6 over x plus 8 equal 4 over x plus 3. So we cross multiply. 6 times x plus 3 equal 4 times x plus 8. Distributive property, we have 6x plus 18 equal 4x plus 32. Subtract 4x from both sides, and you'll have 2x plus 18 equal 32. Subtract 18 from both sides, and you'll have 2x equal 14. Divide both sides by 2, and you get x equals 7. Therefore, the solution is 7. Finally, on number 10, we have a line segment that bisects one of the angles. So we apply the triangle angle bisector theorem, which is 6 over 5 equal 2x over x plus 6. Cross multiply, we have 6 times x plus 6 equal 5 times 2x. We have 6x plus 36 equal 10x. We subtract 6x from both sides, and you have 36 equal 4x. Divide both sides by 4, and you'll have 9 equal x. Therefore, the solution is 9. So we have used the 3 theorem, the triangle proportionality theorem, the mid-segment theorem, and the angle bisector theorem to solve our problems. I hope that you have a wonderful and blessed day.